Hello and welcome back to Calculus 3, section 12.3, Limits and Continuity. We are going to just recycle what we learned in Calculus 1, basically in chapter 2, and adapt that for Calculus 3 environment. So, going back to our Calculus 1 life, the way I describe limits is limit computes the y value of the function, but it computes it in a completely different way than what you are used from your pre-calculus experience. So when you have that f of x is equal to, let's say, 3x minus 1, and you want to compute f at 5, you plug in that 5, right, and you get 14. And this is your pre-calculus. On the other side, you had the limit as x approaches 5 of 3x minus 1, and you also had 14. But the way it was computed, it was very different. 3x minus 1 graphs as a linear line through -1, and the way you would compute is you would go to 5, and then the line would go straight up and bounce into 14. So the line goes straight up and bounces to, so this is your pre-calculus world, where the calculus world of computing the same thing says that you are supposed to approach this number 5 from two sides. If you approach from the left, then all of the x values before 5 will be giving you the x values climbing up the line, which would be the arrow going up the y value towards 14. And if you approach from the other side, which would be the blue approach, I call this Romeo and Juliet in Calc 1. So if you approach from the other side, the x values will be marching down the line, right, producing those y's, and we will have the motion from the other side. And as you can see, they collide at 14. So what happened for the limit? Limit computed at infinitely many points around 5 and inferred the answer 14. Said all of these numbers point towards 14, so answer is 14. Where pre-calculus computed at the point. So these two methods compute the same thing in a very different way. And they both have their strengths and weaknesses. Because pre-calculus cannot compute when you have open circle, right? If you have a function with the open circle going like this, if you try to compute at that point using y equals f of x, and you try to figure out what's f of a, the pre-calculus will come up with does not exist. Because the method is to shoot the straight line up to the function, and when you hit the function, it bounces off. Well, when I shoot the straight line, it goes right through the hole, and it never bounces off. Oh, they have a class? Wait, I thought this was the... Let me see. No, because we always have to... Well, we have to find a new home. We'll have the part 2 of this one. We have to move. And we'll be back. Yes, yes.